Welcome to my channel. This is another time with Mr. Angel Agbo. Um, Today we're going to learn um, the topic that we've been learning in our previous lesson. We've started it. We have watched the first lesson under this topic, which is variation, and I taught you um, the first type and the second one because there are four types in this variation. There are four types of variation. We have treated the first one, which is direct variation, and the second one, which is inverse variation. In case you haven't watched them, you can check my video, the previous one before this particular one. You will see. Please check on that particular video before you watch this one. So today we are going straight to the third type of variation and the fourth type, which are joint variation and partial variation. Yes. So in direct variation, my previous video, I told you that direct variation is a relationship that happens between two quantities, between two variables, between two objects, two people. Likewise, inverse variation. But the only difference between the inverse variation and direct variation is under direct variation, the relationship is direct. When one is affecting positively, it also results in that other one to be affected positively. For instance, if A is increasing, B will be increasing. If A is decreasing, B will be decreasing. But under inverse, if A is increasing, B will be decreasing. If B is decreasing, A will be increasing. So, but both of them have a relationship between two objects, two quantities. That is just it. But under here, the relationship upgraded. So under joint variation, we can simply say that joint variation is a combination of direct variation, the one we treated before, and inverse variation. It's a combination of the two to result in joint. And that is why the name is what? Joint. Because it's a combination of direct and inverse variation. So partial variation is another level whereby you're going to have um, addition of quantities and you have two constants. So we're starting with joint variation first. Please, in case this is the first time you are coming across my video, don't forget to hit on subscribe button for me. Thank you so much. We can move, right? Yeah. So under joint variation, I'm going straight to give us an example. Let's say they use x and y again. X is directly proportional to y and inversely proportional, and very inversely rather. Let me put the word, let me use the word varies as what? Let's use n, right? N squared. When x is equal to 4, y is equal to what? 2. And n is equal to what? 3. Find the relationship between them. Find y, or let's say find, we can find anyone. Let's say find y when x is equals to 2 and n is equals to 1. Okay. Now s is directly proportional to y and varies inversely as n squared. Inversely as n squared. When x is 4, y is equals to 2 and n is equals to 3. Find the relationship between them. They have a relationship. Find y when x is equals to 2 and n is equals to 1. Okay, from our former lesson or the previous one, I explained how a relationship can be formed. So from here, we are going to interpret this statement. It said x is what is directly proportional to y and inversely vary inversely as n squared. This is just it. So we have it this way: s equals to ky divided by n squared, where our k is equals to what? Constant number. Now, from here, this is the relationship we're going to use, the expression rather, we're going to use to solve everything. Don't forget that. So from the question, our s, the first phase of PHASE, x equals to 4. So we're going to substitute everything into this formula. S equals to 4, right? 4 is equals to k times our y is equals to 2 divided by our n is equals to what? 3. And it's 3 squared because n is squared. Now we have it this way: 4 is equals to 2k divided by 9. But remember, 4 is just like 4 divided by 1 is still the same as 4. But for understanding and clarity, we can put it this way so that it will be balanced. Now we are going to cross multiply. 2k times 1 is 2k, right? We have it as 2k. 4 times 9 will give us 36. Now we can say that we can now divide the both sides by 2 so that we make k to stand alone or to find the value of k. So we divide the both sides by 2. We are going to have k equals to 36 divided by what? By 2. Now from there, our k is equals to what? 18. Now we're going to move ahead and find what? The relationship. So find the relationship between them. Since we have gotten our k, the only thing we need to do now is to replace this k here with 18. So the expression is s equals to k y divided by n squared. N squared or n raised to power 2. Then we have x equals to 18y divided by n squared. So this is the relationship between them, or find them in terms of x and y. That is just it. Now the last question says Find y when s is equals to 2 and n is equals to what? 1. So from there, we substitute everything into this particular formula or this equation. Now we are going to have our x now here as 2, so we substitute it as in 2 equals to our k is 18. 18 times what? Y divided by 1 raised to power 2 is still 1. So we leave it out this way. So we have it as 2 equals to 18y. So you know that what we need to do right now is to divide the both side by 18. So I will take it to this side. 2 equals to 18y. Then we have it as y is equals to 18 equals to 2 rather divided by 18. So 2 here 1 or 2 here 9. So we have a y equals to 1 over 9. This is the value of y, and we are done with what? Joint variation. You can see that under direct variation in our previous video, the relationship is direct. But under inverse variation, you have something like y is directly or inversely proportional to this. But under joint variation, you see that it's directly proportional first and inversely again is a combination of the two. So this is how it's being done. Thank you for watching. Please, in case you haven't hit the subscribe button, you can do it right now. Thanks for watching, and I really appreciate it. So we are going straight to the second one, which is what? The partial variation. Partial variation. So before that, I want you to hit on subscribe button for me, and I'm going to release the video right now, and I want you to what? To follow me. Don't go anywhere. Just hold on. You will see the next video under this partial variation. Don't forget, partial variation involve simultaneous equation. Please take back. You will see it. Thanks for watching. Nice having you. Love you.